Hi, my name is Amin, and I'm going to talk to you about psychology of estimation today. Um, so, first of all, a little bit about myself. I'm the founder of AY Technologies. We are a software development company in Vancouver, British Columbia, in Canada. And what we do is that we help software tech companies and software development companies with their software development and estimation and planning in general. As part of what we do, we call it the Roadmap Workshop, and it's a workshop that is influenced by a lot of experience that my team and I had over the years developing and architecting software systems, and also it's highly influenced by psychology of how our brain works. Over the years, I have seen, I've been part of a lot of projects. I've seen that a lot of them, the main focus was on speed. What is the speed of delivery or a speed of development? And that was the main KPI for measuring the progress. And it's good from the company's perspective. If you can deliver software faster, it's better because your cost is lower and you can get to the market faster. But what happens when you're going fast is that you lose quality. And that loss of quality sometimes results in the project failure, which is at the end is a loss for the company. But the question that I was dealing with a lot was that why do we make more mistakes when things are moving fast? Because if you think about it, we know all those answers in our brain. If things are slow down a little bit, we are making the right decision. It's only when the things are going fast that we are making those wrong decisions. So our brain knows the right decision, but it's making the mistake. Why that is happening? So I started my journey with that question, and that's when I got introduced to the book Thinking Fast and Slow by Daniel Kahneman. In the book, Daniel Kahneman describes how our brain works and how different parts of our brains are in charge of different type of decision making. And he also talks about a lot of cognitive biases and how that affect how we behave. This is an example. How many of you have seen this? Show of hand? Perfect. I don't see any hands that were not raised. But basically, if you have seen this before, you know that the two lines are the same length. But still, every time you look at it, every time I look at it, my eyes are telling me the line in the bottom is shorter. But I'm just overriding that because I know the two lines are the same length. I'm overriding that ruling of my eye saying that the two lines are the same length. This is the type of cognitive biases that Daniel Kahneman was talking in his book, and it goes deeper than that. And basically, one simple fact about this is that you cannot reverse the way you perceive information here, right? You can only identify them and then add rules in your brain that help you to override the wrong decisions with right decisions. And that's the goal of my talk today. It's to try to show you a few cognitive biases that we have and how they affect the estimation of projects. And then we talk a little bit about how can we fix them. What are the things that we can use to fix those cognitive biases? So you've heard me saying Daniel Kahneman's name a couple of times so far. Who is he? He's a psychologist best known for his work on psychology of judgment and decision making. He is the founder of behavioral economics, the whole field, based on his work done by the work he's done with Amos Tversky on prospect theory. He's also the only psychologist who ever won the Nobel Prize in economics. So he's a big shot in psychology. In 1979, Daniel Kahneman and Amos Tversky coined the term planning fallacy to describe plans and forecasts that are unrealistically close to best case scenario. And the piece of that that's stuck in my mind was that best case scenario. That project that was supposed to be straightforward, but then when you get into it, the unexpected happens and it takes way more than what you imagine it would take. The interesting fact is that although that happens more than once, over and over again, it seems that we are not learning from the mistakes that we are making in that estimation. And that's where the fallacy comes in. And they're saying that these plans that are very close to best case scenario almost all the time can be improved by consulting statistics of similar cases. So if you look at the other project that was similar, you would have seen that your estimation and the actuals were not the same. And you could have stopped yourself from making the same mistake. So that is basically the part that planning fallacy comes, and like we want to discuss a little bit more about that. But let me show you a couple of examples of planning fallacy. An interesting one, I got this from the book as well, is the Scottish Parliament building. In 1997, the Parliament building was started with budget of £40 million. By June 1999, it was raised to £109 million. In April 2000, legislators requested a cap on budget for the project. It was set on £195 million. In November 2001, they demanded final cost of the project to be estimated. The estimate was £241 million. So far, 6 times the original. But it goes further. In 2002, the estimate rose twice, finishing the year at £295 million. 3 times more in 2003, and getting to £375 million. And then in 2004, the project completed with the total cost of £431 million. That is more than 10 times the original estimated. So this is an example of planning fallacy that I'm talking about. And if you think that it's just government is always bad at this type of project, well, you're wrong. A survey in 2002 in US homeowners showed that people that were doing a kitchen renovation, on average, the estimates for them, what they expected was $8,658, but in fact, the actual cost was more than 38 grand, more than double. And that's a small project. That's not a huge project that we are talking about. Still twice the size. And, well, of course, if you think the software is not like that, you'll be wrong again. There is a Wikipedia page, actually, with title List of Failed and Over-Budgeted Custom Software Projects. Just you can go and Google that, and you can see a long list of them. An example of that, very recently, is healthcare.gov. That project was estimated to be £95 million, and the actuals for that was $1.5 billion. $95 million, and the actuals were $1.5 billion, more than 15 times. Now, this is the thing. I know some people from healthcare.gov project, they are all competent people. And I have made the same mistake, and I consider myself competent. The question is, how do we competent people make these big mistakes? And that is what I'm trying to figure out. And in order to understand that, you have to understand how brain works. You have to understand that our brain consists of 2 systems, working, 2 very distinct systems, working simultaneously together. Psychologists have given the 2 systems many different names, but because I don't want us to clutter our judgments about them, I'm going to go with the simple System 1 and System 2 names from that. It is from the book as well. System 1 is in charge of fast and intuitive reactions and instantaneous decisions that govern most of our lives. When you press on a brake in your car, when you're about to have an accident, that's your System 1 acting. System 2 is in charge of deliberate type of thinking, involved in focus, deliberation, reasoning, analysis, and doing complex math, programming, coding, all of that are coming from System 2. I cannot go very deep into the 2 systems, but if you want to compare the 2 systems, System 1 is automatic and fast. System 2 is lazy and slow. System 1 takes little or no effort to work. System 2 takes energy and mental focus. System 1 is on all the time, and you cannot turn it off. System 2 is lazy by default, is off. If you want, you have to turn it on to be able to use it. And actually, one more thing here is that when we think of ourselves, we always identify with our system 2. But in fact, most of our daily actions are done, or all those decisions are made by system 1, not the system 2. And that's where all the illusions and cognitive biases come in. Look at this again. It's basically your system 1 telling you that the line in the bottom is shorter than the line in the top. And it's telling you every time you look at this. It's like when you see a word, you always read it. You cannot stop yourself from reading a word. That's your system 1 that you cannot turn it off. But then system 2 knows that you're about to make a mistake. So it wakes up, overrides the decision, and says, no, the 2 lines are the same length. And then it goes back to sleep. That's how the 2 systems work. System 2 only comes up when it knows that you're about to make a mistake. And it only knows that when you have identified a cognitive bias, like in this illusion. So now I want to get into the 3 forces that I think are very important for making mistakes when it comes to estimating any projects, especially on software projects. The first force I want to talk about is called what you see is all there is. Basically, our brain it's one of the traits of our brain is that the information that we have, we treat that very differently than the information that we don't have. So basically, it's one of the features of this associative machine that we call our brain that it will only represent the activated states. So any information, if it's not coming from the memory, even unconsciously, if it's not retrieved, it might as well not be there. That basically means that your system 1 assess the truth of a fact, the truth of a statement, by how coherent the story is, not by how much information you have on that or how much information you don't have on that. It does not consider that into the calculation at all. Here's an example. So read this sentence and tell me what's the first answer that comes to mind. Will Mindy be a good leader? She's intelligent and smart. The first answer that comes to mind is yes. Why? Because it's coherent with the story. It does not consider that you don't have enough information to be able to answer that. But the first thing that comes to mind is yes. And I can change that. If I just change the 2 adjectives to be, will Mindy be a good leader? She's corrupt and cruel. The first answer changes to become no. We jump to conclusion. We jump to the answer very fast. And that's our system 1 in effect. Basically, what you see is all there is the combination of having a coherent seeking system 1 and a lazy system 2. System 2 does not wake up when you want to answer that quickly. It only wakes up when you start deliberating, start thinking about that a little bit more. Now we'll see, in future slide, we'll see how this affects our estimation. The second force is prediction by association. And I call this the curious case of Tom W. Consider that Tom W. is a new enrollment, this year's enrollment to New York University, and you're given this fact that New York University takes 1,000 graduate students each year, and they are distributed between different majors, business management and marketing 28%, all the way down to computer science 5%. Now, if I ask you, how likely is it for Tom W. to be in each of these fields, for you to rate them 1 to 6, 1 being the most likely, 6 being the least likely? What you would do is that you will use the statistics that I have here, and you tell me that Tom W. is more likely to be in business management and marketing because more people go to that. And you're right. You're using, so in absence of any other information, you're using the base rates that are given to you, and you're making the right decision. But now consider, I give you some extra information. The following is a personality sketch of Tom W. written during Tom's senior year in high school by a psychologist on a basis of psychological test of uncertain validity. Tom W. is of high intelligence, although lacking in true creativity. He has a need for order and clarity and for neat and tidy systems in which every detail finds its appropriate place. His writing is rather dull and mechanical, occasionally enlivened by somewhat corny puns and flashes of imagination of the sci-fi type. He has a strong drive for competence. He seems to have a little feel and little sympathy for other people and does not enjoy interacting with others. Self-centered, he nonetheless has a deep moral sense. So now, let's go back to the same question. How likely do you think he will be in each of those fields? Rank it 1 to 6, won't be the most likely. Who thinks he's in computer science? Show of hands. What about engineering? What about social sciences? What about business management? Okay. So far, this group has given me the best answers. Still, almost 95% of people were wrong. The correct answer is exactly the same as last time, because the information that I've given you up there, it has no value. I'm telling you that. It has uncertain validity. It's a psychological test, and it's not representing necessarily any information related to the question. Now, we make this mistake all the time. And basically, we are letting System 1 use the stereotypical information that are given to us that has no validity to affect the decision that our System 2 is making. Because the answer to that question is too hard for System 1 to make, and it's always System 2 that makes that, creates that answer. But yet, System 1 is affecting that answer. The reason is that System 2 is lazy, wants to answer a question, and then says, System 1, what do you think about this? System 1 is too dumb for that question to answer. So it changes the question. So it answers, instead of answering how likely is it for Tom W. to be in computer science, it changes the question to is the description of Tom W. fits him being in computer science? So those two answers are completely different answers. And that is one of those forces that affects our estimation greatly. The third force that I want to talk about is anchoring. How many of you guys have heard of anchoring? Perfect. So for those of you who don't know, we start with a question. What's the percentage of African nations in the United Nations? Anybody knows that by heart? It's not an answer that anybody knows by heart, usually, if they haven't looked it up, maybe the same morning. They asked the same question. Amos Tversky and Daniel Kahneman ran an experiment in University of Oregon. And they gave the same question to the graduate students. But first, they showed them a wheel of fortune. So the student goes in, turns a wheel of fortune. They rig the wheel of fortune so it stays only on 10 and 65. And then they asked the graduate students this question. People who saw 10 on the wheel of fortune guessed 25%. And the people who saw 65 on Wheel of Fortune guessed 45%. That's the average. So although they knew that the number that they saw on Wheel of Fortune has no relativity to the answer that they're giving, they still used it because when you're faced with a question that you don't know the right answer to, your mind tries to get clue from anywhere that it can. And although that 10 on the Wheel of Fortune is not related, it's a number, and your mind is now anchored on that. And now you know that probably it's more than 10%, so you adjust for that, but you can only adjust so far from the number that you were anchored on. The same thing happened for the people who saw 65. They knew that it would be less than 65, but they only adjusted so far, and the result is that the average between the two groups is completely different. So now that we have seen three forces, I want to go deep into each one of them and see what are the impacts on estimation. What you see is all there is, which basically means that when you don't have enough information when you're estimating a project or task, you're going to make mistakes because you're not going to include all that information. So what are the things that you will hear when this is happening? Because everything that we're talking about today is about recognizing that you're about to make a mistake, and then try to compensate for that. So what you will hear is anything like, give me an estimate. if you want to go deep in that, that will slow us down. Or just give me a ballpark estimate. Or I can't wait until we have all the details. If you hear these things, that means that you're about to make a mistake based on the cognitive bias of what you see is all there is. What are the ways that you can deal with that? More detailed user story is one way if you're doing Agile Scrum. One of the tools that I found very useful is the definition of done. Because definition of done is that you only make it once, but then when you read that, you're going to start estimate for the things that you would not estimate otherwise. Like QA. QA is one of those things that are always underestimated or not estimated when you're doing estimating a task. Because it's not there, so, and what you see is all there is, so you do not estimate for that. If you can write acceptance criteria for your user story, it's going to be huge, because acceptance criteria is always goes on the edge cases, the cases that usually take more than what you estimate, and also it's something that you can easily miss. And then if you were asked to give them a ballpark, give them a ballpark. Give them a range. Estimate in ranges instead of estimating in absolute values. And one other thing I did not put in here, but as human beings, we are so bad at estimating time. So stick to your user stories and don't make them equal to like 1 day or 1 hour or anything like that. That will be a good thing in general. So the second one, the prediction by association. This one is a little bit harder to notice because it's not very direct. Because you would think that the information that you're getting is relevant. But when you're estimating multiple tasks in a row, that means that this is probably going to happen. Or when you're estimating without looking into the data. The best way that you can stop this from happening, and this is huge in the planning fallacy in general, is that use data as your outside view for your project or task. Look at the data that you've gathered on similar tasks or similar projects and see how far you were from your actuals and your estimates. That's what we are doing. We are basically, what we are doing at AYTech is that we are estimating each single task and estimating each project. But then, at the end of a sprint, or at the end of the task, or at the end of project, we are collecting the data on how much time we actually spend on finishing that task. That average over time gives us that we know that for a front-end task on React Native, we usually have 20% underestimation, so we always add that. Or for a Python task, when we are doing a project on Django, we usually do 30% underestimation. So we add that to our estimation. That is the best way to deal with prediction by association. And the third one is the anchoring. When does it happen? Usually when you hear anything like, every company usually have at least one of these people that in a meeting, they are the chatty ones. Usually the project manager, I'm guilty of that charge all the time. And they start by saying something like, I think we should be able to do this in 1 month. And then they ask a question, what do you think? When you hear that, you're already anchored on 1 month. So if you would usually estimate that project to be 5 months, now you're anchored on 1, and you know 1 month's going to be not enough time. You're going to extend your timeline, but maybe you go up to 3 months instead of going 5 months. You're still underestimating 2 months, your project, because you were anchored on 1 as a simple estimate for that project. The second one is something like, do you agree that we can do this in 1 sprint? Or something like that. Usually then, if you hear a number, somebody asking you to estimate something, but then giving you a number for it, they either deliberately or by mistake, they're anchoring you on that number. And be careful about that. Tools to use, one of the things that a lot of companies are using is the planning poker. I would say you can go even 1 step further, ask everyone in the team to estimate all the tasks before the meeting. Because even in planning poker, the first time that you estimate something going to anchor the second time that you're estimating and the third time and goes ahead. If you're doing planning poker, next time look at how different your estimations are at the start of planning poker and how close they are to each other at the end of planning poker. People adjust as they go. Estimate separately before the meeting, or even one step further, you can randomize estimations. So you can, because estimating a small task at the start, gonna anchor estimating a big task. Anchoring happens all the time, and we have to be very careful about that. So randomizing the list of tasks that you want to estimate, gonna help a lot with that. So these are the three forces and three ways for you to identify them. But basically, at the end, the whole point is that you have to have your system one trained to identify when it's going to make mistake, when those cognitive biases are happening. Similar to the case of the two lines, if you understand that you're about to make mistakes, you can go and override that. And that's basically, you can train your system one to do that in the same speed, but still you have to slow down and let system two to override that for you. So know your cognitive biases, identify them when they occur, and adjust your estimates accordingly. And use as much as data as you can. I have heard this a lot from people saying that this project is unique, or this task is unique, I cannot estimate it, I cannot use the data from other projects or other tasks to do this. But you really can, because no project is completely unique, and everything you do gonna have the same impact. If you can look at your data and adjust for that, it will help you a lot. So I think we have time for questions. That's great. But if you want to ask me questions privately later, it's my email, Twitter, and LinkedIn. Connect me on LinkedIn or follow me on Twitter and let me know what you guys think. I think we have time for questions. So if you have questions, I will take that. I don't see any hands, so you're either shy or I've explained everything. Go ahead. You have data about prior projects, right? So anything that you have prior, like you're starting with 5 new people in a team and you're trying to estimate a project in software development. Look at the average software development data that you have. Like you can find something similar to it and adjust for it. And it happens all the time. Like the average is a very good tool to use. And as you get better, as you get more data, you can then make better adjustments. You can maybe adjust one set of tasks 20% and the other set 40% instead of everything 30%. But even that 30% at the start gonna help you. Okay, guys, thank you very much. I will be in the... Thank you. Ask me questions if you had I will be in the hallway or during the 2-day event, and then we'll see you guys around. Thank you.